After we deal with the sequence data by using 1 gram or 2 gram 1 hot encoding, you can perform principal component analysis to reduce the dimension. And what else we can do? So we have a data like this, right? We have different features like here. Here, okay, usually that is 1 hot, 1 gram, right? There will be a lot of 1, 0, so on and so forth right here. But this data right here is 1 hot. HL means it is hook log, it is the log shared with you. And LI means it is a list of lists. So basically it is a table. So that is the data right here. What else we can do if we have such kind of table? The first thing is UPGMA, which is hierarchical clustering. So basically you simply just use very simple 3 lines of code. You simply just import those libraries to your Python environment. And if you have such kind of tables, list of lists, okay, and you can simply just plot it. We read this figure, explain it. So there are 31 instances, okay, in the x-axis. The y means height, or that is the distance. That means we have 31 samples right here and would like to calculate a distance match, and it becomes like this. As we mentioned before, the distance between sample 1 and sample 1, okay, the distance should be 0, right? Because the distance between you and you is 0. Good, 2 and 2 is 0, 3 and 3 is 0, and so forth. 31 to 31 is 0. That means the diagonal, the distance measured, the diagonal value are all zeros. So this cell, that means the distance between sample 1 and sample 2. And this one, this cell means the distance between sample 2 and sample 1. The distance function should be symmetric. 中文就是说，距离公式通常都是对称的哈，所以1跟2的距离还有2跟1的距离应该是一样的啊。So since it is symmetric, we have symmetric distance function. So these two values should be exactly the same. So we only have to calculate the value right here, the bottom half triangle. And we don't have to do this by ourselves. These 3 simple codes will help us to convert the original table, which is a 1 hot 1 gram table, to distance matrix, and then the algorithm use this distance matrix to perform UPGMA, as we told you before. There are some samples right here from here to here. Their distance from the perspective of 1 hot encoding, they are exactly the same, which means we cannot distinguish them by using 1 hot 1 gram encoding table. So there are several instances right here, but when we combine them, the height is 0, which means they are exactly the same from the perspective of 1 hot encoding. 好，你可以看到下面这一堆哈，就是这个紫色这一堆啊，他们会全部粘在一起，是这里大概有10几个人嘛，哈，10几个 sample 嘛。他们因为在计算那个 distance matrix 的时候啊，他们在 1 hot encoding 1 gram 的这个概念上，他们的那个横条啊，就这个横条哈，长得都一样啊，因为他们都在这个 sequence 的事件里面用了一样的事件哈，所以他们的比如说1跟2的距离就会一样。所以他们在做 UPGMA 的时候，他们在合并的时候，他们高度是0，好，所以他们看起来就没有办法有个高度嘛，好，但是实际上他们高度是0的哈。那他们高度是0的话，就合并，你们就会发现紫色这些人，他们在 1 hot 1 gram 的这个概念下、观点下，他们做的事情都一样，所以我们会认为这个 sequence 是一样的。但是再讲一次 ，1 hot 1 gram 是已经抹除掉所有 order 的概念的，所以他们并不是很适切。好，所以你可以试着做 1 hot 2 gram 啊。那或许这10几个人他们的差异在 1 hot 1 gram 上看不出来，可是在 1 hot 2 gram 上或许就看得出来了，因为他们 sequence 可能就长得原生的 sequence 长得不太一样。好，英文再讲一遍哈。So maybe there are 10 data points right here. From the perspective of 1 hot 1 gram, they are exactly the same how they use this event x0 to x10. Maybe they're exactly the same. So we cannot distinguish them from the perspective of 1 hot 1 gram. But as we know, because we remove all the older relationship information from when we convert the original sequence to 1 hot 1 gram table. So maybe if you would like to preserve the older relationship, you can use 1 hot 2 gram, 1 hot 3 gram, 1 hot 4 gram tables to represent those original 31 data points. And further, for example, 2 gram 1 hot table. And then you can use this 2 gram 1 hot table to perform distance matrix, to calculate the distance matrix, and then perform UPGMA to help you to draw such kind of hierarchical clustering figure. And then maybe, because you add some older information in your 2 gram table, right? So maybe you can distinguish these 10 data points, so that enrich your feature. However, because we only use 1 hot 1 gram, so the UPGMA figure look like this. So here, okay, we have a lot of samples that exactly the same, and right here also they're exactly the same, and right here. But after that, we know the relationship between different clusters. There are 3 different clusters right here, 2 large clusters and a small one. And from the perspective of distance matching, it says, for example, group A, group B, group C. It says they can further combine together to form another cluster which is larger. Okay, we call it BC because they're close enough. And then there will be another cluster D. It contains 2 samples. And further, it says, okay, right here, cluster A and cluster BC can be further grouped or can be further clustered. So here we have another group called A, B, C, and so on and so forth, so on and so forth. So that you can understand the relationship. The relationship means the distance between each data point or the distance between each cluster by using this UPGMA hierarchical clustering method. That is how we use this very simple code to draw such kind of information, okay, so that we can understand those 31 data points. Another one is right here, so that's a little bit different. Sometimes we don't have such kind of 1 gram, 1 hot encoding. Sometimes when we obtain those data, okay, we only have distance matrix. So this cell, that is, how do we create distance matrix from 1 hot list? That means sometimes we only have distance matrix. So these codes right here is how do you build such kind of UPGMA graph by using only distance matrix. If you only have distance matrix from line 28 to line 33. But if you have 1 hot 1 gram matrix, you use this code, line 6 to line 8. I think UPGMA is good enough for you to understand the relationship between different instances, different samples. So next one is dot matrix. We skip this graph. Let's take a look at this one, which is more easy for you to understand. You have to notice that origin point is right here. 我们在画 dot matrix 的时候，那个原点在左上角，不是在左下角。这个你要特别注意哈，就是有的时候你会发现这件事情。This technique comes from genomic analysis， 就是这个技术啊，这个 dot matrix 哈 ，dot matrix 这个技术是来自于那个 genomic 就是基因啊哈，基因组哈。基因组序列的分析的技术哈，所以它是医学用的。可是我们后来发现它在很多其他领域，尤其在序列分析上还蛮有用的，所以它后来就变得比较 well known 了。Dot matrix original invented by some genomic analysis, but we believe that those sequence analysis techniques can be very useful for some other domains. So we use this right here. You have to notice that the original point is right here, left top side. Is not left bottom side. View it in this way. Here we have sample 1 and down here that is sample 2. Dot matrix is a technique, is a method that helps you to analyze 2 sequences, not 3, not 1, but only 2, because you can only draw this figure in a 2D surface. So we use this dot matrix technique to help us to analyze 2 sequences. Okay, so right here 0 means the first event in this sequence. So 200 right here. So we have a lot of different events along with axis, right? So in total, sample 2 has around 1,200 events. At the top side, we have another sequence, sample 1 right here. For example, that is the first event, the second event, the third event. Okay, so at right here, first event, second event, third event, 4, and so on and so forth, right? So how do we draw this dot matrix? Here is a cell, right? The cell means the first event of sequence 1. That is sequence 2, right? So this cell, okay, this red cell, that means is the first event in sequence 1, exactly the same as the first event in sequence 2. If they are exactly the same, please draw a dot in this cell. 所以我再讲一遍哦，这个 dot matrix 它的用法是这样子哈，就是横轴是一个 sequence， 然后纵轴是另外一个 sequence， 然后它的这个每一个格子啊，你这1号跟1号相对这个格子，表示说 sequence 1号的第一个 event 是不是跟 sequence 2号的第一个 event 是完全一样的 event。如果它们是完全一样的，你就在这个格子里面涂满颜色我们那个上面画的是黑色不过现在这个画是红色The second cell is right here, right? That means the green cell means it's the second event of sequence 1. Is it exactly the same as the first event of sequence 2? If they're still the same, and you draw a dot in this cell. If they are not exactly the same event, then you left it blank 中文再讲一遍所以右边这一格是什么？右边绿色这一格是指说 sequence 1的第二个 event 是不是跟 sequence 2的第一个 event 是一样的？如果是一样的就涂满颜色，如果是不一样的你就不要涂色，让它是空白，可以吗？好 So how many cells, how many dots in this dot matrix? There should be around 1,200 times 1,200 dots in this surface. So you compare them one by one. Okay? If they are the same, then you you plot a dot in that cell. If they are not the same, then you left it blank. 好，所以在这个平面上，如果你这样画的话，它应该就是1200乘1200个格子，然后你就去看那个格子的纵轴跟横轴是不是同一个 event， 是就画点，不是就留白。Okay, so here is the first example which I draw right here, and you take a look at this one. I write a function to draw this figure. Okay, this function is quite simple. It's called create dot matrix. So you just take a look at it. Okay, but I only have one parameters right here. That is because the function I create, the sample in the x-axis and the sample at the y-axis is the same sample. 好，中文再讲一遍哦。你去看那个 create dot matrix， 真的 function 是我写的可它只吃一个参数，那个参数是吃一个序列。好，为什么我是这样设计呢？是因为我们在画这个 dot matrix 的时候这个 function 它的 x 的那个 sample 就是 sample 1跟 y 的那个 sample 就是 sample 2，在我的设计里面它们是同一个 sample。也就是说呢，你在 x 轴画的这个序列跟 y 轴画的这个序列是同一个序列这是你现在看到的这个样子那为什么呢我换回英文讲What is the reason why I use the same sample to draw this such kind of a dot matrix? That is because the sample at the x and y axis is the same, right? So basically here, this cell means the second event of sequence 1 and the second event of sequence 2. As I mentioned, the sequence 1 and sequence 2 are exactly the same sequence, so basically it is still the same, and so on, so forth, right? Basically, because the sequence 1 and sequence 2 is the same sequence, right? So basically, in this diagonal line, all the cells on the diagonal line, they are all dotted. 就是因为 sequence 1跟 sequence 2我们现在设定是一样的嘛，对不对？所以在斜对角那个地方不是就会一定会填满的点嘛，对吧？因为第一个 event 跟第一个 event 一定一样嘛，第二个 event 跟第二个 event 一样嘛，第1200个 event 跟第1200个 event 也会是一样嘛，所以它在斜对角上一定会是完全填满的一条直线，表示的是说在这个斜线上 sample 1跟 sample 2是完全一模一样的。好，这是第一个点。Okay, so that because sample 1 and sample 2 are exactly the same, so in the diagonal line, those cells, those dots should be filled. Okay, that means the event 1 and event 1 exactly the same, event 120 and event 220 those are exactly the same. However, we can see that there are some dots, they are not on the diagonal line. 就是中文就是说虽然我们知道斜线一定会点上点嘛，对不对？因为一号 event 第一个 event 跟第二个 event 一定一样嘛，第二个 event 跟第二个 event 一样，所以你如果把在 dot matrix 上你选取的 x 轴跟 y 轴是一样的东西的话，一定在对角线上一定会有点，对不对？可是我们可以发现，在这个 dot matrix 上，你会发现在非对角线的地方会有一样会有点产生。那些点是什么意思呢 ？Okay, let's take a close look at this specific dot. It looks like a line, right? What exactly it means? So we change another color. Okay, the purple one. That means there are several consecutive cells. 这是一连串的一个 cell. Okay, they are filled with colors. That means so you draw a line, vertical, and right here. For example, maybe that is 420, and we draw a line right here. 这大概多少？大概是 for example 100. Okay, this specific cell is dotted. It means in sequence 1, it's 100的第100个event is exactly the same as the sequence 2's 120th event, and so on and so forth, until maybe that is 120, and that is maybe that is 440. That exactly same. However, as we mentioned before, sequence 1 and sequence 2 are the same sequence because we do this, right? So that means in this sequence, in this specific sequence, the sequence of 100 to 120 is exactly the same as 420 to 440。好，中文的意思就是说，如果我们看到这里有一条斜线。consecutive 的斜线的点，它们构成了一条斜线，然后你就去对它的 x 轴跟 y 轴，就会得到它的位置嘛，对不对？啊，第100，所以说这个 sequence 的第100个到第120个，刚好跟这个 sequence 的第420个到第440个是一模一样的，它们是重复的序列，这个序列发生在100到120这个地方，还有420到440之间 ，and as we mentioned before。Those are sample 1 and sample 2 are exactly the same. So there should be another line right here. So that should be 440 should be. 这整个大 matrix 应该是要对称，因为我们这 x 轴跟 y 轴是一样的东西，所以你在左边发现一条线是100到120，然后420到440，你会在这个 diagonal 线的另外一侧发现另外一对是420到440，还有100到120线，没有错嘛，对不对？好，回去好好想想这个问题。So by using this star matrix, we can find there are several patterns can be found. They are symmetric to a diagonal line. If you find there's a pattern right here at one side of the diagonal line, you can find a pattern exactly on the opposite side. 就是你可以在对称的那边找到一样的 pattern. So that means if you want to analyze a sequence, of course you can use UPGMA, you can use one hot 1 gram to 1 hot 2 gram encoding to describe such kind of data. However, there's another way, okay? You can draw a dot matrix by using exactly the same sequence on the x-axis and y-axis, and to observe if there's any subsequence. Subsequence 中文就翻译成是sequence 的片段哈。You can observe that if there's any subsequence like this one, if there's any subsequence which appear or happens in the entire sequence multiple times， 就是说这个 subsequence 在100跟120之间出现过一次，然后在400跟420跟440又出现过一次，这个是你可以用看的，光用眼睛看这个 damage 就可以观察出来的。So let's take a look at this specific pattern right here, okay? 这是另外一个例子哈。Take a look at this one. How do we analyze this data? There is a dot, right? So we draw a vertical line right here. We draw, there's a dot right here, right? So draw a vertical. The green dot will be exactly the same because there is a dot, right? There's a dot right here. Because there is a dot, and it infers that this special event is exactly as the same as this event right here, right? And so on and so forth. So if you see a line like this, that means this event happens right here and here. And also you can see there's another event right here. So there's another sequence of event right here. That means these 3 different lines are all the same. 中文的意思是说，你会看到这个 damage 上有很多斜线的这个图样和 pattern 哈。那如果它们平行或是垂直是可以对得上的，那就表示比如说这3条线嘛，你看左下角的那条线跟中间的那条线，它们是垂直可以对得上的嘛，对不对？所以表示它们的每一个点，它们上面的 event 是一样。然后中间这条线跟右边这条线，它们的在水平上是可以对得上嘛，然后它们的线也是一样的，那就表示说这3条线。它们里面的每一个 event sequence 会是一模一样，这个需要好好回家想一想。好，我先就跟你们讲，如果它们的线是平行的，或者是垂直是一样的，它这里面的每一个组成，比如说 A B C D F G 就会是一样，好吗？所以你就可以发现说，哦，原来这边呢会有一些一样的。OK, so that is one of the way you use dot matrix to observe a sequence. So that's one of the way. Okay, next is another example. It's right here. Create dot matrix. However, currently I have 2 sequences. These 2 sequences are from 2 different malwares. However, they are from the same family. So that sequence is same family, malware family, but they are two different samples. By draw the dot matrix by using these two different samples, okay, the result is right here. Each of them has 400, around 400 events in this sequence. So that is sample 1, okay, that is sample 2. Because there are two different samples, so you can observe that right here. What exactly the red line? It is a pattern, right? A pattern you find in this dimension. What does the red line mean? That means around 110, and that is maybe 250, and that is around. So that means we have two different samples, but by using the dot matrix, I found a pattern right here, which is a line that indicates that the subsequent of sample 1 from 30 to 170 event is almost exactly the same as the event you find in sample 2 from 110 event to 250 event. Okay, so by using the dot matrix, you can identify if sequence 1 and sequence 2, whether they have commonly shared subsequence within their sequence, even if they are not at the same position. 好，中文意思是说，用 dot matrix 啊，那我们现在 x 轴跟 y 轴是两个不同的 sample 嘛，对不对？然后我就画出它的 dot matrix， 然后就突然发现有一些 pattern， 就是有些线段或是正方形会出现。那以这个例子来说哈，就假设这个例子来说，就是你发现 sample 1的第30号到第170号的那个 event 刚好跟 sample 2的110号到250号的 event 是一样的，所以你才会在那边看到一条线。好，那这个方法就是告诉你说 sequence 里面有一些 subsequence 有可能是 commonly shared among different samples， 对吧？好，可是它们就不在相同的位置上，因为我们知道 sequence 虽然这就是 sequence 的问题。sequence 的问题就是说，如果你这样子看的话，你会不会觉得 sample 1跟 sample 2它们的 sequence 其实有蛮大部分是相似的啊？因为30到170还有110到250这边起码内容绝大部分都是相似的。可是如果你用 one hot encoding 的话，你就会发现，好吧 ，somehow 你还是可以把它们相同的 event 把它标记成都是1嘛，对不对？可是顺序就不见了。然后再来是位置也不见，对不对？位置也不见，所以面对 sequence 来说呢，其实 one hot encoding 就是还可以，但是不够好，所以通常来说不够好。Okay, so next you can see that there's another sequence, okay, subsequence, okay, at which I use blue color, okay, right here, all right, and this pattern, okay, this blue pattern. Around, okay, maybe 20 to 60. There's a subsequence right here. You can find the pattern from the matrix, dot matrix, and you can see that this subsequence occurs in the sample 1, okay, from 260 to 300. And in sample 1, it occurs from 20 to 60. So that we can see that this sequence, okay, and the blue sequence and the red sequence, they are not in order. 中文的意思就是说，你会看到蓝色这边会有一个新的 pattern 嘛，对不对？所以它就会出现在这个地方。可是你发现它在 sequence 2，它在 sample 2里面是先出现蓝色，然后才出现红色的嘛，对不对？因为它在20到60就出现了，然后红色是110到200。可是，在 sample 1里面，蓝色的这个区段是在260到300才出现的，那红色是在30到170就出现，所以发现有很多 subsequent 它是错位，对吧？是错位的。那错位的意思就是什么？意思是说这个 subsequence 应该本身就表示某一个特别的事件的集合，而这个事件集合呢，跟红色是前后顺序相反是没有关系的，因为我们知道嘛 ，sample 1、sample 2都是恶意程式嘛，也就是说。恶意程式1号先做了红色的坏事，才做了蓝色的坏事。可是恶意程式2号 sample 2， 它是先做了蓝色的坏事，才做了红色的坏事，对吗？我们直观解释上来说是这样。And even more, okay, we have another sequence right here. Okay, that should be quite close to the blue one. Okay, the green subsequence. Those three different subsequence, they are ordered. Might not be important for malicious sample 1 and sample 2. Because for sample 1, the sequence of these three is red one first, and blue one, and green one, right? For sample 1. But for sample 2, it is blue one first, and then green one, and then red one. They are important subsequence, but their order might not quite important. And however, as you can see, okay, we use the black color. The rest of the sequence from maybe 250 to 400, okay, right here, sample 1 and sample 2, they do not have commonly shared subsequence in this area. 中文就是说，在250之后，以 sample 2来说，在250到400的区间里面，它就跟 sample 1几乎不像了，因为它没有看到，你没有看到有很多点点嘛，或是可以成一个 pattern 的样，所以在250到400之后 ，sequence 2就做它自己的事情了。sequence 1在170到260之间。还有300到350之间，还有大概309到400之间啊，它们就不相同了，就是sample 1跟 sample 2就没有相同的部分了。所以这就揭示了一件事情，就是说坏人，因为我们说过嘛，这2只恶意程式是同 family 的，对不对？它们只是2个不同的 sample。也就是说，坏人在制作这些 malware 的时候啊，可能有3件重要的事情是坏人想要做的，就是红色线、蓝色线跟绿色线。可是有很多所谓独特的事件啊，比如说250到400这个 sample 2的这个事件，是坏人要在这个变种，我们说 variant 里面做的。可这个变种做的事情跟 sample 1完全就已经天差地远啊。那 sample 1当然也在其他空白的地方，比如说170到260的之间，有做一些其他的事情，可是做这些事情跟 sample 2没有看不出来有任何关啊，但他们都做了重要的事情，好吗？这是中文的解释哈。So that we can see that for sample 1 and sample 2, for sample 2, from 250 to 400, okay, there are several events invoked by sample 2. However, those events are not related to any event of sample 1. From the perspective of malware family, okay, we say these two variants, they belong to same family because they have long enough event subsequence. The red one, blue one, and green one, they are the same. Although they are not at the same position, but those subsequences are almost exactly the same, right? So they both belong to the same family, which is maybe correct. However, there are some other events taken by the sample 2 from 250 to 400. But those actions, those events are not related to any event in sample 1. So we say those are variant, okay? Hackers or malicious malware makers, they sometimes they have to do some commonly shared things. For example, a red one might be connected to a server to download something. The blue one might be to steal your information. The green one, those events might be modify your operating system, something like that. But there are some other things, okay, which is unique to this variant. For example, we can see that sample 2 do some other event, okay, right here, okay, but they are not related to any event regarding to sample 1. So that is how you can compare two different malware samples, two different sequences, okay. Although such kind of technique, dot metric, they are originally used for analyze two DNA sequences, so that we can compare two DNA sequences and try to figure out if there's any subsequence, any DNA subsequence which is exactly the same from one DNA sequence to another sequence. But we use these things to analyze sequence, which is quite good. So after you observe such kind of dot metric, and then you can think about how do I use a table? How do I design a table that can describe what I see in the dot metric? Apparently, one hot encoding is maybe good. So you can partially, okay, add some 1 hot 1 gram features as part of your feature, or maybe you can do some 1 hot 2 gram features as part of your feature table right here, because 1 hot 1 gram can help you to describe what kind of event has been used by sample 1 and sample 2. 1 hot 2 gram can describe what kind of consecutive events are used in sample 1 and sample 2. However, there are some other events, there are some other features that you should describe. For example, okay, I see a line right here. How do I describe a line? Maybe you can use 4 gram, 5 gram, 6 gram, longer gram to help you to describe such kind of line. And you can use this concept as a features, as part of your features to create such kind of feature table, so that you can enrich your feature, so that can help you to distinguish between sequence 1 and sequence 2. Okay?